Hello again. In this video, we're going to find the derivative of the natural log of x. Okay, so the way we're going to do this is, let's say y is equal to ln of x, and we want to find dy dx. Now, we're not going to find dy dx directly. What we're going to do is we're going to turn this into its exponential form. So remember, y is equal to ln of x if and only if e to the y is equal to x. And that's because if you switch the input and the output over here, in other words, the x and the y, then you need to use the inverse function. The inverse function of ln happens to be the exponential function with the natural base of e, because the base of this logarithm is also e. Okay, so natural log of x equals to y can be rewritten as e to the y is equal to x. Again, you're just switching the input and the output and changing it to the inverse function. Okay, so what we're going to do is we're actually going to find the dy dx using implicit differentiation starting with this equation. Now remember, the first step in implicit differentiation is to take the derivative of both sides of the equation with respect to x. So let's do that first. Okay, of course, on this side, you're going to get 1. The derivative of this x is equal to 1 with respect to x. Okay, on the left-hand side, though, we're going to have to use the chain rule because this is a composition of two functions. You have e raised to the x power as your outer function, and then y is your inner function. We're assuming y is a function of x here. Okay, so if you form a composition with these two functions, you're going to get e to the y. And anytime you take the derivative of a composition of functions, you have to use the chain rule. And then the chain rule, if you remember, just basically says you take the outer derivative and you multiply it by the inner derivative. Okay, so here the outer derivative would be the derivative of this function, which is e to the x. But then notice you have to evaluate it at the inner function. And when you evaluate that at the inner function, you get e to the y. Okay, so that's our outer derivative. And now we just have to multiply that by the inner derivative. Of course, this is the inner function, and we're taking the derivative with respect to x. And so we just get dy dx. Okay, so the derivative of e to the y with respect to x using the chain rule is simply e to the y times dy dx. Okay, and that's supposed to equal 1. Now we're just going to solve for dy dx by dividing by e to the y. Okay, and so that leaves us with dy dx is equal to 1 over e to the y. Then e to the y is actually equal to x, so this can be written as 1 over x. Okay, and so now we've just found the derivative of natural log of x because natural log of x is equal to y, right? So we've just found the derivative of y, in other words, the derivative of the natural log of x. It's 1 over x. Okay, so we're going to extend this a little further. And we're actually going to find the derivative of natural log of the absolute value of x. Okay, so let's talk about that. So the natural log of the absolute value of x is actually equal to a piecewise function. It's equal to the natural log of x if x is positive. It's equal to the natural log of negative x if x is negative. Now, notice that 0 is not included here because this function is undefined when x is 0. And that's just because the natural log of 0 does not exist. So I'm just going to include that just to be clear. Okay, so what we want to do is find the derivative of this natural log of the absolute value of x with respect to x. And we're going to break it up into two cases. If x happens to be positive, then the derivative of this natural log of the absolute value of x, that's the same as finding the derivative of the natural log of x. And that's because these are the same thing if x is positive. I mean, that's what this piecewise function is telling us. The natural log of the absolute value of x is simply the natural log of x as long as x is positive. Of course it is. The natural log of 5, the absolute value of 5 is the same as the natural log of 5. That's because this x value is positive, right? It's equal to 5. We already know the derivative of this natural log of x. We just found it. It's 1 over x. Okay, so what if x is negative? All right, well, if x is negative, then the derivative of natural log of the absolute value of x is the same as finding the derivative of the natural log of negative x. And that's because if x is negative, then the natural log of the absolute value of x is actually the natural log of negative x. And that should make sense because if I take the natural log of negative 3, here x is negative 3, so it's a negative number, then that's equal to the natural log of the negative, right? The negative of the x value, which would be the negative of negative 3, since negative 3 is the x value. Right? The opposite of the x value. That's another way to say that. So the opposite of this x value would be positive 3. Okay, so if x is negative, then the natural log of the absolute value of x is the same as the natural log of negative x. And so we can take the derivative of this to find this derivative. Okay, but this is a composition of two functions. The inner function in this case is negative x. And then the outer function would be ln of x. So if you compose these two functions, you get this function. And so we're going to have to use the chain rule to find this derivative, since it's a composition of two functions. So again, the chain rule says that the derivative of a composition of two functions, f composed with g, is f prime evaluated at g, which is the outer derivative, times g prime, which is the inner derivative. Okay, so f prime in this case would be 1 over x. But then you have to evaluate that at g of x. So it's really f prime evaluated at negative x. And that gives us 1 over negative x. Okay, and then of course g prime would be the derivative of this function, which is just negative 1. And so this is our outer derivative and our inner derivative, and then we just have to multiply them together to get this derivative. Okay, so it's 1 over negative x times negative 1, right? The outer derivative times the inner derivative. But that just gives us 1 over x. And so an interesting thing happens here. The derivative of the natural log of the absolute value of x is 1 over x in both cases, right? Regardless of whether x is positive or x is negative, we get the same thing. And so this is a general result. Now, please bear in mind that the assumption here is that x cannot be 0. First of all, the natural log is not defined when x is 0, so it doesn't even make sense to do that over here. And of course, 1 over 0 is undefined as well. So this is true as long as x is not 0. Okay, and so in the book, this is theorem 315. The derivative of the natural log of x is 1 over x, as long as x is positive. Now, the reason x has to be positive here is because natural log of x is only defined for positive x values. Then the derivative of the natural log of the absolute value of x is 1 over x for all x values except when x happens to be 0. Okay, so x cannot be 0 in this case. And then there's one other result that we can sort of derive from this, is that if you were to take the derivative of the natural log of u, where u is a function of x, or sorry, the absolute value of u, where u is the function of x, then you're going to have to use the chain rule to find this. So let's talk about that. Okay, so let's suppose this is a function of x itself, right? So u is some function of x. So this is really a composition of two functions now. This is like natural log of x, which is the outer function, being composed with this inner function, which is u of x. Okay, so in order to find this derivative, we're going to have to use the chain rule. Okay, so f prime of x, well, the derivative of this we know is 1 over x, right? We just found it. And then you have to evaluate that at the inner function, which of course is just u. And so you just get 1 over u of x. Okay, so that's our outer derivative. And of course the inner derivative is just u prime. Okay, so you got to multiply these together, right? The outer derivative and the inner derivative. And a more compact way of writing that, of course, is just say u prime divided by u of x. Okay, so in the case where this is simply natural log of the absolute value of x, the derivative would be 1 over x. But if this function in here happens to be a function of x, right, which we'll call u, then the derivative of the natural log of the absolute value of u of x is actually u prime of x divided by u of x. And that, again, is just coming from the chain rule. Okay, so in the next video, we'll do some examples where we use this theorem. But in this video, I just wanted to show you where these derivatives came from. Okay, hope you found this video helpful. Thank you for watching. Bye-bye.